Hello students. Dear students, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Dear students, let us see the preparation of aldehydes by Rosenmund reduction. Rosenmund reduction. So it is very simple students. The name is Rose and Mund. So Rose and Mund reduction. What it is? Acyl halides, for example benzyl chloride. This is benzyl chloride. When I treat it with hydrogen in presence of palladium carbon, so it is going to reduce halogen to hydrogen, and this carbonyl compound is going to be stable when only the condition is I have to add barium sulfate. So in this barium sulfate, the sulfur which is there as sulfate, this sulfur is going to act as poison for the activity of palladium, where barium, this sulfur behaves as a poison towards this palladium, and it stops at aldehyde stage only. This is aldehyde, where this chlorine is reduced to hydrogen. If I do not add this barium sulfate, very important students, if I do not add barium sulfate, it is going to undergo further reduction to alcohol. Yes, so Rosenmund reduction is use of barium sulfate. Yes, so similar reaction we come across during alkynes. So alkynes to alkene can be done by palladium carbon by the addition of, yes, so barium sulfate. So sulfur is a poison where it stops at aldehyde stage. In Lindlar's catalyst, yes, it stops at alkene stage. So Rosenmund reduction, one method. So specifically we are going to get aldehydes, and the second method is from nitriles. Let us take nitrile, and when I treat it with stannous chloride, tin dichloride, stannous chloride in presence of HCl, I am going to get aldehyde. Yes students, so let us take one example and see. And this intermediate is going to be double R CH double bond N H. So this upon hydrolysis, it is going to give aldehydes. Yes, so it is very specific reagent where stannous chloride is going to reduce only nitriles. In this case, double bonds are intact. Let us take double bond containing compound. This double bond, if I do using hydrogen palladium, this is going to be reduced to alkane, RC. This double bond is going to reduce to single bond. However, if I use this SnCl2 in presence of HCl, I am going to get exclusively aldehyde. This double bond is going to be intact, where nitrile is going to be reduced to aldehyde. So nitriles, we can do preparation of aldehydes. And very important reagent which has been asked in all sessions is diibal, diisobutyl aluminium hydride. reagent which is specific for the reduction of nitriles. Diisobutyl aluminum hydride. It can be written as diisobutyl aluminum hydride, or you can get it as like this. The representation is important, students, because you may get in exam in any form, or you can write it as dibol H, or you can get it as dibol H, no space. So what is this reagent? It is very important reagent where this aluminum is having hydride, which is negatively charged hydride. Yes, it is a metal, is going to have positive charge. This hydride is going to have negative charge, and isobutyl 1 2 3 isobutyl. You can have the structure like this also. In some exams you may get like this structure also. So this is the overall reagent dibol H, and it is very pyrophoric, means it burns in air. Pyrophoric, and its handling is very important. Dear students, I made a video how to handle these reagents. Please go through that if you have any doubts, because its handling and their quenching, means how to destroy after use, it's very important, and you are going to use this kind of reagents at higher classes or during your research only. So dibol H is a reagent. Yes, so pyrophoric, aluminum hydride is a pyrophoric reagent, so its handling must be done under very specific conditions. Anyhow, regarding our chemistry, so this diisobutyl aluminum hydride specifically reduces nitriles to aldehydes. So this only one hydride is going to be given. So this nitrile, when I add diisobutyl aluminum hydride, it is going to give aldehydes. This is one of the methods for the preparation of aldehydes from nitriles. And not only this, and another one more category of compounds dibol H is going to reduce. What is this? What is that? It is ester. Ester to aldehyde. So in carboxylic acids I am going to explain in detail. For example, if I take long chain acid ester CH2 taken 9 times, and this is ethyl ester, and when I treat it with diisobutyl hydride, I can write dibol H. Dibol H, it is going to give aldehyde. This is very important concept, students. You have been asked in 2019 JEE mains number of times. In all sessions you got dibol H based questions. Yes, so it is stopped at aldehyde stage only. However, in place of dibol H, if I use LaH, lithium aluminum hydride, it is going to reduce this aldehyde also to alcohol. So LaH is not going to be used. Dibol H has to be used. So dibol H is very specific reagent where nitriles, this is cyanide, I can say cyanide or nitrile, and esters. Please remember or write down somewhere. Dibol H is going to give aldehydes, and esters also aldehydes. However, during really speaking, when you are doing synthetic chemistry and you have to do very fast reactions and you have to do very fast workup under anhydrous conditions, otherwise it is going to reduce further. So simply as soon as add your dibol H and do the workup. Anyhow, that is practical problem. So when it comes to preparation of aldehydes, you can prepare from nitriles and esters. Then very important name reaction sessions come, students. So there are 4 types of reactions available for the preparation of benzaldehyde from toluene. Let me take one by one. When I take toluene, this is toluene, students, and treat it with chromyl chloride, CrO2Cl2, chromyl chloride. This name reaction is Etard reaction. Most of the times you will get questions based on name reaction. So Etard is the name of a scientist. In previous, just now what I said, Rosenmund is a scientist name, and stannous chloride reaction is a Stephen reaction, student. Just now I forgot to mention Stephen reduction or reaction, right? So when it comes to this benzaldehyde preparation, Etard reaction, chromyl chloride, it is going to form chromyl complex. This is chromyl complex, chromium complex. When I do further hydrolysis using acid hydrolysis, it is going to break here to give chromic acid and the benzaldehyde. And this benzaldehyde preparation, these four methods are very specific and important, and which are has to be remembered throughout your life, because these questions you may get during your interview also. So if you are already completed your PGR degree and you are going to work as a chemist, and these questions are sure, I am sure you are going to get these questions, right? Anyhow, so this is one method, and the second method is oxidation using chromium trioxide and acetic anhydride. Toluene, chromium trioxide in presence of acetic anhydride. What is acetic anhydride? CH3COO. I can write like this also. Acetic anhydride, right? So acetic anhydride in presence of chromium trioxide, it is going to oxidize toluene to benzaldehyde. And the intermediate is, you may be asked this intermediate also. OCOCH3 and OCOCH3. Yes, so this intermediate is going to hydrolyze upon acid hydrolysis to give benzaldehyde. This is second method. And the third and important commercial method for the preparation of benzaldehyde is from toluene by halogenation followed by hydrolysis. Toluene, when I do halogenation, free radical halogenation, this is alkane. How to do halogenation? Use chlorine gas in presence of light, that is HNu. HNu is a light. Yes, students. So light, you are going to get dichloro benzol. So two chlorines are going to be added. This upon hydrolysis at 100 degrees centigrade, these two chlorines are going to be hydrolyzed to take up water and to give benzaldehyde. This is very important method and commercial method. Yes, student. So it is a commercial method for the preparation of benzaldehyde. Next. And one more very important name reaction under the preparation of benzaldehyde is Gattermann-Koch formylation or aldehyde preparation. What is Gattermann-Koch reaction? Anyone? Yes, students. Koch formylation. What is this reaction? Take benzene and treat it with carbon monoxide in presence of dry HCl. So it takes up carbon monoxide in presence of anhydrous aluminum chloride, or I can use cuprous chloride, CuCl. Yes, so this takes up aldehyde carbon monoxide to give benzaldehyde. Yes students, I have made video on detailed mechanism of this Gattermann-Koch formylation. You can go through that. That link I am going to give below of this video. So these are the common methods for the preparation of aldehydes. Let us see the preparation methods for the ketones. Thank you students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. We will meet again with carboxylic acids. Till then, bye, sayonara, all the best, arigato gozaimasu. Bye students.